Okay, hello. This is our code for the project. Well, we have a map in name agency list. This is to create the agency list. The agency list is a tree map type, and then we have the first method here is add edge. U represent node, V represent the node that you connected to. As we can see at the below, we use this add edge method to create agency list. Like for example, for node 1, it connected to 2, 3, 4, and 5, and this happened to all of the node here. So we have the create multiple one for appendix A, B, and C. And then this is get edge count. This is actually to count the number of edges. We count it by going through the for loop. As you can see here, there are actually two returning type. We need to change accordingly. For appendix A and B, we will return count over 2. It need to divide it by 2 because for this kind of formula, it will actually double the amount of edges because it is an undirected graph. But for appendix C, it is a directed graph, but there is actually one edges that is undirected. Hence, there will be one edges that will be count twice. That's why we will minus 1 so to get the exact amount. And then the first is breadth search. We have a set called visited, and then a list called traversal order. We declare the start time, and then we proceed to do the breadth search by looping through the agency list. While not visited, we will create a queue, and then while the queue is not empty, we will add it to the traversal order, and then we will create a linked list for neighbor. While neighbor is not null, we will proceed to looping through the neighbor, and we will proceed to do the queue until finally the loop is over and we get the traversal order. And then we declare an end time. The duration is end time minus start time to get the exact time, and then we print all the result. And here we will call the method get edge count to get the number of edges here. That's all. Okay.
So for the DFS recursive, we need initial set, visitor, and also the list traversal order. So also we create the long start time. The time will start beginning. So for the for loop, we will check the node is visitor or not. If not have any node inside that, we will call the DFS helper. So turn to the DFS helper. When we enter the node, we will initial is that is visited. So to preventing infinity loop, to make sure all the node is to be proceed one time. The for loop is until all the node has been visited. So the for loop will stop. Then also the time will count end.
So hi everyone. So AKBAR is already present the DFS, and the WOM is already present the DFS recursive. So I will explain the DFS iterative. The first, the set integer visitor traverse. Visitor is mean that they will remember which node we already received, and the traverse order is set the order of our work, and the stack is help us go deep into the graph memory. And the like one said, the long start time is mean we record the start time, and the stack push start is pushing the first node onto the stack. So where no stack is empty, while stack is not empty, we will put the top element from the stack to process it. And if the node haven't been visited, we mark it and add it to the traversal order, like the coding we write. And the linked list neighbor equal ALIF token, it means that we will get the current node neighbor and we reverse them to match the order to recursive DFS. So the last is for integer neighbor, reverse neighbor. It means that for each unvisited neighbor, don't worry, we will push it onto the stack to receive later. That's all of the DFS iterative. Thank you.
Okay, this is the sample run. First for appendix A. This is the traversal order and all of the information for appendix A. And then we will proceed for appendix B. Yes, we need to change it here. This is for appendix B. Yes, all of this is for appendix B. And then lastly for appendix C. This is the note. And then, like I said earlier, for appendix C, actually the edge count method, we actually need to change the return type from divide by 2 is to return count minus 1, because 1 undirected graph. So here, become like this, the traversal order. That's all from us. Thank you.